A radical expression is one that contains roots. The number under the radical sign is called the radicand. All positive real numbers have roots, but negative numbers do not. The perfect squares such as 4, 9, 16, 25, 36, and so on, all have roots that are whole numbers. And all other positive numbers in between, such as 2, 3, 5, 6, 7, 8, 10, 11, and so on, also have roots, but they are approximations only because they are irrational numbers. Negative numbers do not have roots. A negative root multiplied by its identity, another negative root, produces a positive number. For example, negative 2 times negative 2 equals positive 4. Thus, the square root of positive numbers can be both positive and negative, leaving negative numbers without square roots. For example, if 3 times 3 equals 9 and negative 3 times negative 3 equals 9, then the square root of 9 can be both positive 3 and negative 3. And the square root of negative 9, for example, cannot be found. To summarize, a radical expression, also called a radicand, is any expression found under the radical. Moreover, negative outcomes of radical expressions are not real numbers. For example, what values of x will make the expression a real number? When x equals 0, 1, 2, 3, or 4, the radical is not a real number because the result is a negative radicand. However, x values of 5 or above are possible. The answer is x is greater than or equal to 5, and we can say that any number 5 or greater gives a real answer. Another example. What values will make this expression a real number? Because squaring a negative number gives always a positive answer. In this example, all real numbers, including all negative numbers, are values that would make the radical a real number. Another example. What values will make this expression a real number? X could be any real number. We use the absolute sign to emphasize that in this particular case, you could also include negative numbers. Another example. What values will make this expression a real number? We have to check what values of x in the expression under the radical will make the whole thing equals to 0. 5x plus 7 is greater than or equal to 0. Subtract 7 from both sides. Divide by 5. Answer: x is greater than or equal to negative 7 over 5. Solving for x, we see that any value greater than negative 7 over 5 will make the radicand 0, which is where the positive answers begin. Another example. What values will make this expression a real number? We use the absolute value sign again. X could be any real number, including negative numbers, because whatever is under the radical, it will get squared anyway, and squaring makes things positive. Another example. What values will make this expression a real number? 1 over 9 is already positive, and because y will be squared, then y could be any real number. And like before, we show this by using the absolute sign. Another example. What values will make this expression a real number? Well, this looks like a perfect trinomial square. If it is a square under the radical, it will turn positive anyway. So, factor first. X and y could be any real number. Again, notice the use of the absolute bars that would make any negative answer positive. I'm finishing this section by showing you how radicals are reduced. However, please remember that we're talking about non-negative real numbers. Real negative radicands cannot be reduced. To simplify a radical means to reduce the radical to the point of not having any perfect squares represented in the radicand. In other words, every 2 of the same number, or base, under the radical sign represents 1 outside the radical sign. The rest stays under the radical. This is because the square root, as shown by the small 2 that is part of the radical sign, means 2 roots for every radicand. For example, to simplify the square root of 18, we use prime factorization. Because 3 times 3 is 9, the 9 gets simplified as the square root of 9 equals 3. Answer, 3 radical 2. But the 2 cannot be simplified and stays as a radicand. This is what radical simplification is. Another example. Simplify the square root of 16b squared. Use prime factorization to simplify the radical. Every 2 values under the radical represents 1 value outside the radical sign. Answer, 4b. Because it is a perfect square, radical sign is gone. Another example. Simplify the square root of 25b. Use prime factorization to simplify radical. 2 5s under, 1 5 outside. But the b stays under the radical because there is only 1. Another example. Simplify the square root of 125a cubed. Use prime factorization to simplify radical. 2 5s and 2 a's come from under the radicand, and a 5 and an a stay. Another example. Simplify the square root of y to the 7th. Use prime factorization to simplify the radical. How many pairs of y's under the radical? 3. So 6 y's come out and 1 stays. One more example. Simplify the trinomial. The trinomial has a common factor, 3. Factor it and you'll find a perfect trinomial square. Do you recall from the previous chapter that when factored, perfect trinomial squares yield 2 identical binomials? If you have 2 of the same under the radical, they come out as 1, and the 3 stays under the radical.